For this particular video, it seemed to make more sense to work with the worksheet itself. I'm hoping that my camera will allow me to show you how these problems are done without me getting in the way of all of the problems. So the first problem was one we did in class. It was calcium hydroxide used to neutralize acid spills, reacts with hydrochloric acid according to the following unbalanced equation. And the unbalanced equation isn't actually there. I'll try to write large so we might be able to see this. So it's calcium hydroxide plus hydrochloric acid. Yeah, in an ideal world I would write solid and aqueous, but that's not the real intent of the problem here. Will yield, taking a look, this is a double replacement reaction. The only possible products would be calcium chloride and hydrogen finds hydroxide. Now, since I see there's a chloride, a Cl2 here, that means I definitely need 2 hydrochloric acids, and then I need, these hydrogens will find hydroxides and make, and again in the states you would have calcium hydroxide as a solid, hydrochloric acid as an aqueous solution, calcium chloride as an aqueous compound, and then water in liquid form. So that's where we start. That is almost a balanced equation. One thing that is missing, I need 2 waters. Okay, now that might be a little bit messy. Let me fix this a bit. Okay, now if you have spilled 6.3 moles of HCl and put 2.8 moles of calcium hydroxide on it, which substance is the living reagent? So we have, again, I always just like to write down what I know. 6.3 moles of hydrochloric acid and 2.8 moles of calcium hydroxide. Okay, now the question is, which substance is going to run out first? I can do this in a couple of ways. One way is I can calculate the quantity of one of my products. That's what I did during class. The other way is just if all of my hydrochloric acid is going to react, how much calcium hydroxide would I need? So I have my moles already. I did not need to go from units to moles. That's one step that I didn't need to do in this particular problem. But I do 6.3 moles of HCl times, and I just times this, I'd multiply this by my mole ratio, which if you notice, I want my HCl on the bottom, and I want my calcium hydroxide on the top. So 1 mole of calcium hydroxide, just to make it a little clearer, 1 mole of calcium hydroxide, 2 moles of hydrochloric acid. That way my moles of hydrochloric acid cancel out. And what does that mean? That means that for all of my hydrochloric acid to react, I would need 6.3 divided by 2 moles, which would be, according to my calculator, 3.15 moles of calcium hydroxide. That's how much I would need for all of my hydrochloric acid to react. But as we can see, I don't have that much. I only have 2.8 moles. If all of my hydrochloric acid reacted, I would need 3.15 moles of calcium hydroxide. I don't have that. Therefore, 2.8 moles of calcium hydroxide is what's going to be used up. All of this will be used up. I will have some excess HCl. And then it says how many moles of excess reactant remain. So in this particular case, I have to first figure out how much of the reactant is used up. So I would do 2.8 moles of calcium hydroxide. Now, the next step will be to figure out how much HCl was used up. So I would multiply that by my mole ratio, which is 1 to 2 in this particular case. So 2 moles of HCl over 1 mole of calcium hydroxide. Now my moles of calcium hydroxide are canceled out. 2.8 times 2, 5.6 moles of HCl is used up in the reaction. All of my calcium hydroxide gets used. That's how much hydrochloric acid it takes to use it. But the question is asking how much remains after I'm done. So looking at my original problem, I have 6.3 moles of hydrochloric acid. I use 5.6 moles, and I'm left with 0.7 moles of HCl. Now it doesn't specify in this case that I need to change this into any particular units. If I were in the case where I would have to transfer that to units, then I'd do 0.7 moles times the gram molar mass of HCl over 1 mole, so it'd be 36.5 over 1 mole. My moles cancel out. As long as you understand, I'm always trying to cancel out the units I don't want and keep the units I want. This is the same process we've been doing over and over again. Now, second problem, aluminum oxidizes according to the unbalanced equation, which wasn't given, but the unbalanced equation was Al plus O2 yields. And you have to think, what does aluminum oxide look like? It is, aluminum always has a +3 charge. Oxide always has a -2 charge. So the only way you can get a formula unit with all of the charges balanced is Al2O3. If I have 3 oxygens, I'm going to have to figure out some way of getting 3 oxygens over here, or a multiple of 3 oxygens over here. The easiest way to do that, I would have 3 oxygens here. That will give me 6 oxygens, which means I need 2 formula units of aluminum oxide, which would also contain 6 oxygens. If I have 6 oxygens here, 6 oxygens here, I'm good. Except I also have the aluminum, so I have 2 formula units of aluminum oxide. That would contain a total of 4 aluminum atoms. Okay, from there, the question says, powdered aluminum is placed into a container containing 0.30 moles of O2. What is the limiting reactant? Let me first check to see if this is still in the screen. Okay, I'm going to move it up. Very low tech tonight, because in the time it would take me to process this video on YouTube, no one would be awake if I had to process it. So, powdered aluminum, I have 0.048 moles of, darn mechanical pencils, Al, and I have 0.030 moles of oxygen. Those are my 2 quantities that I am given, and then it asks what is the limiting reactant. So again, my mole ratio is 4 to 3 to 2. If I use up all of my aluminum, how much oxygen would I use? I would use the mole ratio in order to figure that out. So I would do, again, I want to cancel out something. I want to keep something on the top. I want to cancel out moles of aluminum, because I have moles of aluminum, moles of aluminum. That's my first step. I want to keep oxygen on top, because if I want to find out how much oxygen would I need to use up all of my aluminum. And that would equal, again, my moles cancel out. I get 0.48 times 3 divided by 4, which would be 0.048 times 3 is 0.144 divided by 4 equals 0.036 moles of O2 is what I would need to react all of my aluminum according to the mole ratio that I set up. As I can see, I only have 0.30 moles of oxygen, so therefore oxygen is my limiting reactant. For all of my aluminum to react, I need 0.036 moles